Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. Now, I do hope you are doing well. In our previous lessons, we established that repeating decimals are rational numbers. Why? Because they can be written as A over B. In other words, they can be written as fraction. So in this lesson, our goal is to go through the steps that we can use to rewrite repeating decimals as fractions. In the previous video, I made you aware that repeating decimals can be written as this, where you have the bar on the number that is repeating itself. So without much ado, let's quickly look at the steps we need to do these conversions. So on your screen displayed is what we call the steps we need to follow. First of all, you let x equal the decimal. Okay, I'll just read through. Then with the question we have on the right hand side, we go through it step by step, and then we'll understand what these are. So first, let x be equal the decimal. Secondly, you multiply x by 10 raised to the power n. Take note, the n we are talking about is the number of digits in the repeating block. So we'll look at what these repeating blocks are. Then you subtract the first equation, that is in step 1, from step 2. And then you then make x the subject. So let's look at how we can apply these steps over here. Our solution. For what we have over here, our decimal fraction is actually a 0.4444. You see, it's continuous. That is what we mean by this bar over here. Okay, so what step 1 is saying is that this decimal we have over here, let's let it be x. Do you see? So I'm going to say let x be equal to 0.444. We know it's continuous, so you can just put your dot over here. Now with this, I'll ask myself, how many numbers are actually repeating? It is 4. It is 4 that is repeating itself over and over again. So it's just one digit. So since it is just one digit that is repeating itself over and over again, I just want to make sure one of the repeating digits comes to the whole number section. And if you understand multiplication of decimals by factors of 10, then you should know that if it is just one we need, that is, if we want the decimal points to move by ones, then we will have to multiply this equation here by 10. You see? So what I'm going to do is I'm going to look for what? 10x. That is, I'm multiplying x by 10. If I multiply x by 10, I'm going to get what? 10x. And if I multiply all of this by 10, it just moves my decimal point once to the right hand side, so that I have 4.444. We can still write 4.444. Why? Because the decimal, it is non-ending. You see? So as we have this over here, what we do is, this is actually your step 1, and this is actually your step 2. So this equation we have over here, let's subtract this equation from it. And what do I mean by that? We are going to write 10x minus, so 10x minus what you have here, so minus x, and it's equal to, since you have subtracted this from this, then we have to do the same also for this over here, so that we have what? 4.444 minus your what? 0.444. Doing that gives us 10 minus 1. You know, in algebra, if we are doing this, we just work on the coefficient. So 10 minus 1 gives us a 9x. So you have 9x equals 4.444 minus 0.444. All these 444s will take out the 444. Then we have 4 minus 0, giving us what? The 4. So making x the subject, would have to divide both sides by what? 9. So dividing both sides by 9, I have my x's, or my 9 cancelling out the 9. Then I have my x being equal to 4 over 9. And we said our x was what? 0.444. Now we are saying x is 4/9. So it simply means 0.444, which was a recurring decimal, in simplest form is actually 4/9. As simple as you see. And all we did was to just follow the rules. Going over the rules again, we have our number, right? So with our number, you let it be equal to x. You see, so you equate it to x. And secondly, you ask yourself, how many numbers are repeating? If it is just one digit, fine. You multiply by 10. If it is two digits, you multiply by 100. The reason why we are doing this is we want one set of the repeating digits to come to the whole number section. So as you see, we were able to bring 4 here. Then we subtract this. We'll subtract, this second one from this over here. So that we have 10x minus x, giving you what? 9x. Then 4 point whatever minus your 0 point, what you have here, giving you 4. Then all you do in this stage is to make what? X the subject. As simple as that. Let's take some few more examples. So for this second question here, we have express 0.15 as a fraction in its simplest form. So following the instructions or our steps, we first of all let x be equal to what? Your 0.15. You know it is the 15 that is repeating. So 15, 15, 15. We can write it this way. Okay. And it continues. Since we do understand, just 2 is fine. With this, it's 2 digits that are repeating. And if you want 2 digits to move, then it means we will have to multiply it by 10 raised to the power 2. 10 raised to the power 2 is what? 100. Remember, it says we should multiply by 10 raised to the power n, where the n represents the number of digits that is what repeating. So I'm going to multiply this whole equation by what? 100. X times 100 gives me 100x. And then multiplying what we have here by 100 would move my decimal point 2 times to the right. So that I have 15.1515, which is still repeating. We now do our subtraction. So we take out this equation from this equation. One simple way you can do it is by using the vertical method, which I'll write for you to see. So this is our vertical method. So we have 5 minus 5 giving us 0. All of this minus all of this will give us nothing. Okay, so they'll just go out. And then we have 15 minus 0. That gives us what? A 15. Then we have 100x minus your x. That gives us a 99x. You see, so with this, we have 99x is equal to 15. And making x our subject, we divide both sides by what? 99. So divided by 99, in which case our 99s cancel out, so that we have x alone giving us what? 15 over the 99. And this is 0.15 recurring, written as a simple or a common fraction. I do hope it is clear now. Now let's look at one different case where you have one other number that is not repeating in the decimal place. So our last example. But even before that, remember the question said in its simplest form. So we can further simplify this. So dividing the numerator by 3, we know 3 divides 15 to give us 5. And it also divides 99 to give us what? 33. So this here will be our simplest form. Now to the next question. Okay, so this last question says express 0.27 as a fraction in its simplest form. Now take note of what is happening here. This 0.27 with the bar is just on the 7. The bar is only on the 7. So it is 0.2777. It is the 7 that keeps repeating. Okay, so how do we answer this kind of question? As usual, let's just follow the steps and then you'll see what we'll do differently. So we let our x be equal to the 0.2777. Okay, then what you want to do is the number that is not recurring, you bring it out of the recurring. Okay, so in this case 2 is not recurring, so let's bring it out, and it's just 1 digit. To do that, we would have to multiply it by 10. You see, so 10 times x gives us what? 10x. And then we multiply this also by 10, so that we have 2.7777. Now, being able to do this, we have actually shifted the decimal to the start of the repeating or the recurring decimal. You see, we have shifted it so that it is now exactly here, where you have only these numbers that are repeating. With that done, we can now start our process. And we said, if you want to work on this, what do? All we need to do is to get one of the repeater to the whole number section. You see, and how do we do that? So it means we'd have to multiply this one and then this by 10 again. You see, so if you multiply it by 10 again, this time around, you are going to get 100x is equal to multiplying this decimal by 10, shift our decimal point to this side, so that we have 27.777, okay, which is recurring. How is this different from what we've done? The only different thing here is that in our first step, we want to shift the decimal that is not repeating before we do everything. So over here, we shifted the 2 so that it separates itself from the repeating decimals. If you are able to do that, then we now use our normal procedure, which says first move one of the repeating, and that is what we've done over here. So our question now is going to deal with just this equation and this equation. So our subtraction is then going to be, as I have said, is going to be what? This, which is the second one, minus this one here. Now, doing our subtraction, we know all these will take out all these. And hence, the most important thing is 27 minus 2. 27 minus 2 gives us a 25. And then we have 100 minus 10. 100 minus 10 gives us what? A 90. So we put our 90 over here with our x, you see. Then making x the subject, we have 90x being equal to 25. So dividing both sides by 90, we have the 90 cancelling out, and our x being equal to 25 over 90. Now we can simplify with 5. So 5 divides 25 to give us 5. Then into 90, we have an 18. And hence, this here is our fraction representation of 0.7777, where the 7 is the recurring one. So this is basically how we can change recurring decimals towards their fraction form. As usual, I'll leave some exercises for you to try your hands on. So here are just 3 you can try on your own. It says express the following as fraction in its simplest form. The first is 0.1 with a bar on 1, 0.63 with a bar on 63. Then the third is 0.16 with a bar on the 6. I do hope this lesson was helpful. This is How Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson. Bye for now. Stay safe.